Plucked from the trash, everyday objects are destroyed. Then transformed by technology, reborn into modern marvels. Bullets are fired into gas grills. Pianos change their tune as bicycle bells. Tissue boxes are pressed into boom boxes. These are the things that are made by destruction. The average recreational marksman unloads about 200 rounds an hour at the gun range. Every time a shot is fired, the weapon spits out a brass casing. That's a whole lot of brass with nowhere to go. Now, spent cartridge casings are being fired up into a hot new item. Masters in Alloy in Allsip, USA collect the casings from local shooting ranges and cook them down into reusable metal. Spent brass shell casings are reshaped into barbecues. The metalworkers at Masters in Alloy melt and mold the bullet casings back into brass bars. The first step in the destruction process is melting. A load of brass casings slides into a furnace that liquefies them at 1,200 degrees Celsius. The molten brass flows into ingot molds. The brass ingots gradually cool as they travel along a slow-moving conveyor belt. Then, they drop off the belt into a bin where they harden. A forklift ferries the ingots into a tumbler. Inside, the bars bounce against one another, scraping off the black coating and smoothing the jagged edges. The ingots roll out, revealing their brassy sheen. A worker stacks and straps the ingots onto a pallet and readies them for shipping. The ingots land in New Hamburg, Canada. Riverside Brass casts brass ingots into barbecue burners. The burner is made from two components: the gas pipe, which feeds an air and gas mixture to the burner, and an H-shaped pipe, which distributes the flame. The first step in the creation process is casting. To shape them into barbecue parts, the brass ingots have to be melted back into liquid. The foundry worker hand loads the bars into a 450 kilogram electric furnace. At 1,900 degrees Celsius, the brass melts down. He tips the molten metal into a ladle and walks it over to sand molds in the shape of the individual burner parts. The worker pours the molten brass into the molds. This process is repeated for the other two burner parts. Once the brass is hardened, an automated arm lifts the molds out of the cast and drops it onto a bouncing conveyor. The vibrations shake the sand loose and freeze the newly formed brass burner parts. They ride along the belt and drop into a bin. A worker rolls the bin into a second shaker. He clamps the piece in place. The machine pulsates to clear the rest of the sand out of the crevices. The metal worker cuts away extraneous bits of brass. The burners are now ready for the next step. A worker rolls the burners over to the machine shop. A technician clamps the H-pipe into a jig. Once secure, the machine drills a row of evenly spaced holes along the sides of the burner to ensure even distribution of the gas-fueled flame. Next, the three burner pieces are welded together. The worker places the brass burner into the sandblaster. She bombards the metal with abrasive particles to burnish the surface and bring out the brass's natural luster. Spent bullet casings have been reformed into shiny new brass barbecue burners. The burners find a new home in a state-of-the-art barbecue, the final stop in their journey from the scrapyard to the backyard. Brass bullet casings have been melted down and cast into burners for an innovative new barbecue. The burners arrive in Kalamazoo, Michigan to complete their transformation. Kalamazoo Outdoor Gourmet make a unique hybrid fire grill. The brass burners will be integrated into their distinctive construction. The barbecue is assembled in 3 stages. First, the steel frame is bent into shape and welded together. Then, the hood is added. Finally, the brass gas burners and charcoal drawer are installed. Step 3 in the creation process is assembly. To make the barbecue body, a worker forklifts a 300 by 120 centimeter sheet of stainless steel and lays it on a table. An overhead crane, equipped with suction cups that won't scratch the steel, lifts the sheet and loads it into the laser cutter. An automated 4,000-watt laser glides on rails, making multiple cuts in the steel. The laser is guided by nesting software, a computer program that maximizes the number of pieces cut from a single sheet so there's almost no scrap metal. Once the sheets are cut, the workers bend and braze the pieces to prepare them for assembly. A worker rivets and screws the stainless steel side panels to the base. With the frame complete, the techs attach the hood and install the gas fittings. The workers use multiple grades of abrasives to buff the metal, polish away any welding seams, and align the grains so the body looks like it was made from a single flawless piece of steel. The installer rests 3 H-shaped brass burners onto the steel supports. He slides in a hybrid drawer designed to burn charcoal or wood. Add the temperature gauge, control knobs, and the company logo, and this grill is ready for summer. A touch of the ignition, and the flame spreads evenly along the brass burners. Spent bullet casings have been melted down and reformed into a high-caliber barbecue that can heat up to 540 degrees Celsius to give the outdoor chef their best shot at a perfect meal. The electric piano revolutionized the sound of music. It can simulate a baby grand or a church organ. Eventually, the electronics wear down, but even after its finale, the electric piano can still produce a sound. And that sound could save your life. Global Electric Electronic Processing in Barrie, Canada takes in 59 million kilograms of electronic waste every year. The salvage techs at Geep smash, sort, and shred electronics. And what they can do with the remnants of an electric piano is making a lot of noise. Electric pianos are recycled into bicycle bells. The first step in destroying an electronic piano isn't complicated at all. A grappling hook takes hold of the piano and crushes it to pieces in its iron fist. A magnet draws the metal pieces from the pile of splinters and tosses them in a bin. The bin of piano parts is loaded onto a conveyor belt. Workers then sort through the pieces, discarding bits of debris. The scrap bounces along a vibrating belt, ejecting the lighter pieces of wood and plastic, while the heavy metal stays on for the ride. At the foundry, the steel is melted in a furnace at 2,000 degrees Celsius. The molten steel flows into a cooling barrel and then pipes into a mold. Red-hot slabs of steel emerge from the molds and travel along a conveyor to be flattened. Rollers exerting 1,300 kilograms of pressure squeeze the steel until it's 3 millimeters thick. The thin steel then travels along a looper and is cut into steel sheets. Piano pieces have been salvaged, sorted, and melted into steel sheets, packaged and prepped for the next phase of their transformation. The steel sheets are stamped and machined into parts for a bicycle bell. The salvage team smash electric pianos to bits, then sort and melt the steel into sheets. The steel arrives in Pleasanton, USA. Peridot is a precision metal manufacturer that uses cutting-edge technology to stamp, shape, and cut into metal. The first step in the creation of a bike bell is cutting. A worker wheels the steel sheets through Peridot's 2,700 square meter facility. The bicycle bell is manufactured with a dome, a hammer that strikes the dome to make a sound, and finally, a mount assembly that attaches the bell to a bike. Workers begin by making a nut that's part of the bell's mount assembly. A worker slides a sheet of steel onto a laser cutting machine. Guided by nesting software, the laser eats into the steel like cookie dough. A powerful 10,000 degrees Celsius spark passes from an electrode to the steel, which erodes the steel and pops the nut out of the sheet. It's programmed to make 100 nut-shaped cuts in the 1 by 1 meter sheet. The nuts gather in a pan under the laser cutting machine. A worker carries the nuts to the machine shop. He uses a manual drill press to mill threads into the nuts. Meanwhile, another machinist rivets the twin pieces of a steel mount. He inserts a pin into the sleeve of the mount. Then, the two ends are riveted together. This is where the bell's lever and hammer will be fixed. Next, workers begin to make the bell's dome. Rolls of brass sheets are loaded into a stamping machine. It cuts and presses the metal into the dome in a fraction of a second. Then, a worker places the dome in a lathe to refine the shape and file off any rough edges. Each dome is then measured to make certain the shape is consistent. Finally, it's tested. Brass is used because it gives the bell a clear, sustained ring. The precision parts are then boxed and loaded. They're heading west. Spur Cycle makes 400 classic bike bells a day in their San Francisco shop. Before the bike bell is put together, the brass dome is polished. First, a worker loads the brass domes into an automated polishing machine. It picks up a dome in its robotic arms and leans it into a spinner buffer. After a quick rub down, the arm drops the dome in a completion tray and grabs the next one in line. At the assembly table, workers put together the bell's mount lever arm and hammer. A worker screws the dome onto the mount. He lubricates the hammer with a drop of oil and packages the finished bell. This ringer is ready to roll. This electric piano was gutted, shredded, and melted, ending on a high note as a shiny new bell that will keep you safe on the street. Because now, they can hear you coming. The average person sneezes 1.4 times a day, and they go through about 250 boxes of tissues in a lifetime of colds. That's the bad news. The good news is, all those boxes can be recycled into a funky new product that's music to your ears. Paperfabrik Vrieden in Vrieden, Germany, recycles high-volume paper waste into reusable cardboard that can turn cold relief into a cool new sound. Tissue boxes are turned into build-it-yourself boom boxes. Inside Paperfabrik Vrieden's 9,000 square meter factory, recyclers mash, pulp, and press old tissue boxes into rolls of pristine paper. The first step in turning tissue dispensers into music makers is to reduce the boxes back into fiber. A forklift carries the bales of tissue boxes and other paper waste onto a conveyor. The boxes drop into a pulper filled with 100-degree water. A rotor agitates the water, breaking the boxes down into a sludgy soup called a slurry. The slurry passes through a screen which strains out any debris. The clean fibers pass through a filter and move to the mill. The mill blends the paper fibers into a watery mulch that's only 1% paper. The mulch drops onto a fast-moving conveyor called a wet belt. Speeding along at 24 kilometers per hour, the water drains through the belt's nylon mesh. A rolling press flattens the mulch and squeegees out more liquid, reducing the water content to 50%. A row of hot cylinders dries the paper. A starch solution stiffens and strengthens the stock, making the paper more printable. Finally, the paper spins through another round of hot cylinders. By the time the paper rolls off the mill, the sheet is a perfect 90% paper and 10% water. A reel winds the paper onto 3-ton rolls. Tissue boxes have been pressed into fresh spools of recycled stock, ready to be shipped out and turned into paper you can dance to. The paper is corrugated, printed, and folded into a DIY music player. Paper recyclers pulp, press, and roll discarded tissue boxes to turn them into spools of brand new stock. The 3-ton spools arrive at P-Well in Birkewere, Germany, who process paper-thin paper into rugged cardboard products. They do this by corrugating, layering 3 sheets of stock into a single cardboard wafer. A worker loads the spools and threads the paper into a corrugator. Inside, hot steam softens the paper. 2 rigid rollers crimp it into rows of little folds, which provides strength and structure. Another set of rollers applies glue to the fluted sheet and sandwiches it between 2 liner sheets. Once the glue is dry, the cardboard slides out of the corrugator. A circular saw trims the edges and a stacker piles the sheets. The stacks of corrugated cardboard ship off to Berlin for a print job. Novak Siebdruck applies colorful graphics to cardboard canvases, including a bold boombox design. Printers load the boombox stencil onto a screen press, and they pour green ink into the press. Then they line up a sheet of pre-cut cardboard. A blade rolls over the stencil, dispensing ink through the screen and printing the graphic onto the cardboard surface. The worker stacks the green printed sheets while they prep for a second color. Next, the printer loads black ink into the press and swaps out the stencil. A second pass of the screen adds black to the two-tone graphic. Time to make this flat graphic three-dimensional. Stange Design cuts and folds recycled paper into cardboard creations for Berlin Boombox. Step 3 in the creation process is cutting. A worker loads the printed cardboard into a die cutter. Following a template, the machine perforates segments of the cardboard that need to be popped out. At another station, a worker inserts the scored cardboard into a press and knocks out the pre-cut pieces. Finally, all the cardboard pieces are then placed in their Berlin Boombox packaging. 2 speakers, wiring, circuit boards, and batteries are added to the kit. The last stage in the assembly process happens at home. A purchaser bends the flanges on the cardboard arms of the cutout. He slots the speakers into the cardboard sleeves, then folds the arms over and inserts the tabs into a center slot and connects the wires to a circuit board and battery pack. He eases the electronics into a cardboard hatch and folds the boombox into its final, funky form. The purchaser then snaps in the volume knob and pops on the handle. This boombox is ready to crank out your favorite tunes. Old tissue boxes have been mulched and pressed into corrugated cardboard, then crafted into a portable player that you can make at home.